T-O-R-C-H. Is it just torch? Yeah, torch. It's not torch to t, it's torch. In my head, I think it's like torch, the way it sounds like it's torch with an extra T. Hello, sir. I'm a computer science undergrad, currently in the 2nd year. Torv is explaining why. So here, let me pull back over here. Let's go back to the previous file. The reason why this part works right here and it didn't cause an error, even though the device was still on the CPU and we called it to go on the CPU, is a Pytorch tensor is already on the CPU, is a no-op, meaning that it simply returns the tensor as is without triggering an error or a stack trace. You got it. Karmook, yep. You're in it now. You're in it. Today I made a simple retrieval augmented generation for the first time with a local large language model. You're part of the future now. You are part of the future when you're doing that. Keep on going. Don't give up. Keep on going. All right. Let's go to Unsqeeze. All right. We got Karmook here, who is a simple a torch. It's a simple torch. Tensor. Example, Unsqeeze. All right. So Unsqeeze.shape. What does this do? I don't know what that does. We're going to find out. All right. So this will be Unsqeezed. Unsqueezed equals Karmook. Unsqueeze, yep. Unsqueeze, like that with an E at the end, yep. Okay, 1. And then I want to print that out. Print unsqueezed. See what that looks like. Okay, see what that is right there. So that just did a reshape, right? Isn't that just a reshape? What does it mean, unsqueeze? To me, that looks like it's squeezing it in further because you're adding an extra dimension. It converted the single-dimensional array into a 2-dimensional array, like a matrix. It created a matrix out of it. So, example, we can do unsqueeze in a nice syntax also, like this. Oh, really? Interesting. I didn't know that. Let's check this out. All right, let's check this out. Karmook colon none, like that. Is that right? Like this? Was this correct here, right here? Does that look right? Let's read that. Comma none. Okay, so we missed it. Hey, look at that syntax. Isn't that weird? Isn't that weird, that syntax right there? That is very ambiguous syntax. What is even going on? It's a slice. It's a slice you get. What was that? All right, so let's do Karmook. We'll do unsqueeze Karmook. There we go. We will do, let's see, and then was it, let me double check. Was that, yes, 1. Okay, so dot expand. Was that expand? 3,2. Was that in a tuple? I think it was in a tuple, right? And no, it wasn't. It was not in a tuple. All right, let's, whoops. All right, let's fix that right there. All right, fix that. All right, so what does this do? I don't know. We're going to find out. So this, interesting. So it's not, so this is like reshaping. It's doing some weird, although, is that extra? It's expanding it. So if we did 5, this will increase, it'll create 5 columns. 1, 2, 3, 4, 5. Hey, there we go. We're figuring it out right there. So we can do Control V like that. So you can see there are exactly 5 columns right here. 1, 2, 3, 4, and 5 right there. 1, 2, 3, 4, 5. Because we expanded it, basically did a copy on it. That's pretty neat. Finished Unsqeeze. Let's do broadcasting, you guys. Let's do broadcasting, which looks like matrix multiplications. Why is it? Oh, broadcast MatMult. Okay, broadcasting MatMult. So let's create a new file. Let's close that. Okay, by broadcast.py. Import torch. Save that. Python. And it's called broadcast, right? Python broadcast. Broadcast. There we go. Perfect. Okay. Left, right, out. So let's see output. Shape, shape, shape. Interesting. So I already basically know this one. We're going to run through it anyway. We're doing some Pytorch. All right. I already know this one. So left equals torch dot, what is it? Torch dot, what were they using? A rand? Oh yeah, rand is good. And then we'll go, was that multi-dimensional? So let's go 2, 2, 2. I want to make it easy. print left. Let's run that really quick. All right, so that gives us some interesting numbers here. And that is a 3-dimensional, right? 3-dimensional. So we've got, yeah, that's 3-dimensional. So that's 3 dimensions. And then there's a 2-dimensional, which is weird. So we're going to take a 3-dimensional matrix and then multiply it by a 2-dimensional matrix. I've not done this before, and I don't necessarily know why you'd want to do this. I've not done this before. Right equals torch.rand, and you go, let's go, see, 2, let's go 6, we might have to, because the dimensions are weird, I don't know what that's going to look like. So we might have to use the original. We might have to use the original, guys. Right, there we go. So right. So this is going to work here. This will be fine when I run this. However, if I try to matrix multiply that, it's not going to work. It's not going to work. Although it might. Let's try it. Out equals left at right. And then we'll print out. Print out. Out. There we go. Perfect. Failure. MatMult doesn't match. It's not going to work. Exactly. Not going to work. Okay. Of row and right need to be the same as the number in left column. And it turns out we sure made it happen. See, look right here. Boom. Success right there. We're figuring things out. Usually it's this right here. And then you compare it with, so go that. Oh, right. V. Wait. Let's highlight that. And then also V. There we go. Perfect. And then we go over here. And this needs to match. There you go. So those numbers that I highlighted on the screen, those need to match. Think of the heart reaction. Okay, so we did some broadcast multi-matrix. Let's do some reductions next. And this will be the last thing we do today. And then we'll do some memes. So we'll do reductions. And then tomorrow we'll do simple indexing, Boolean indexing, and the rest here. Which is, we should be able to get rest done tomorrow. I think so. All right. Broadcast. So we did this. Let's do reductions, and this will be the last one for today. Arrange, reshape, stats, mean. All right, so that's like an average, right? Doing some average. Doing software engineering. If you want to, we stream 5 days a week, Monday through Friday, and you join the right channel. We're doing software engineering. We're going to do some reductions in Pytorch, which I'm not familiar with. It seems like these are like sums, means, averages, things like that. Standard, nice. Okay, we're going to do these. So we're going to try all these things here. So let's do this. We'll do stats. Torch, A range 12, reshape, float. I don't know why we need the float. All right, so that was stats equals torch dot A range 12, right? Dot reshape. Was it 3, 4 or yeah, 3, 4? Okay, 3, 4. Dot float. Why float? Why float? Oh, just wait. No, why float? Oh. All right, float, because it won't be float otherwise. Let's see what that looks like without a float. Print stats, Python reductions. Ah, see, they're integers. And then what happens when we do without float? They're gonna be floats. That's all that does, right? 15 seconds. Do you think? So I read that. Should we develop Skynet? Well, probably not, right? Because it's a sentient thing that takes over maliciously, malevolent, danger zone. I know the Terminator thing doesn't happen. Oh, it's so long. So we got stats. So we printed out the stats. Looks good to me. Let's do a mean. All right, so let's do mean. All right, so let's say print stats mean. Can we do that? Okay, so that is how it works. Okay, so it is averaging it that way. So you can see here on the screen that this average rate, this line right here is averaged. So it's taking that dimension. And what if we change the dimension to the other dimension? So will it give us 4 values? Will it give us 4 values? I'm actually really curious about this. What if we do 0 dimension? Is it going to give us 4 values on the output? Because it's going to look like this. And I think so. I think it's going to look like this. Right here. Control V. Control V. Ashwin Root, thank you for joining, Ashwin Root. Good to have you here. Thanks for subscribing. Welcome on in. Happy Wednesday. Good to have you here. Let's see here. Sorry, I missed some of the chat message. I got really into this Pytorch stuff for a second. You applied for a role because you showed the career page. Oh, you did? Nice. The cause sounds great. I'm on a job search. How serendipitous. Hey, very nice. The sounds good to me. Thank you for doing that. Thank you for dropping in your resume there. Will we ever have AI minds like the culture series from the Lane M Banks? I don't know what that is. You ask a really good question. Nathan? Is it Nothan? Nothan? Steven, we look at our lives. See here. Where are we at? So Pytorch, for 1, 2, 3, this is day 4. So we're on day 4. These are essentially the basics of Pytorch. So if you're interested, 3 days prior, we've been doing this for almost a week now. All right. So that is interesting. What if we did, what is this? Dim, keep dim true? What? What does this mean? What does keep dim true? Okay. Keep dim keeps the reduced dimensions size -1, so the shape still lines up. Didn't it line up before? It's not lining up now? I thought it lined up perfectly fine. All right, so dim 1. Okay, so it's going to want this. All right, so what does this look like? You said keep dim? Keep dim equals true. What does that do? I don't know. Let's find out. It will... okay. Okay. So it keeps the matrix. Got it. Okay. So it's 2 dimensions. When you do the mean with a dimension on which axis you're going to go on, it's going to give you back a tensor with 1 dimension. However, if you wanted to keep the original dimensions of the matrix, you can say keep them equals true, and it will keep. Although I don't know why you'd want to do that. Maybe that's just part of your workflow. There's some interesting items on the screen. Let's check. Let's take a look. I'll show you what we're doing. All right, so we just finished the unbiased part. Let's do the max. I'm actually gonna care. I'm gonna try. The max is gonna. I know what that's gonna do. Print stat. Let's see. Print stats dot max. There we go. Print. Let's make it easier to see. Max. There we go. Perfect. Run this so we can get a little bit of this out. So you said max and then you say dim 1. What is max dim 1 equal? Dim equals 1. So will this give us multiple maximum values? I think the answer is yes. All right, here you guys. So those who are live and paying attention to us right now, we get one last poll for the day. What are you guys going to answer? All right, so on the screen here, you can see line 17, max dim equals 1. Will this print, was it 3 values or